Welcome back to another video on Nina, and in this and the following video we're going to be looking at a new feature of the target scheduler which allows it to work with dual telescopes. Now, we already have in Nina the ability to run dual telescopes, but it works with a quite complicated sequence where if you want to take more than one target, you have to construct your targets one after another in the advanced sequencer. In this video we're going to see just how easy it is to combine complicated target sequences with scheduled and synchronized exposures through two or more camera systems using the Target Scheduler plugin. Let's take a look at Nina and the plugin. So Nina's been loaded, and this particular equipment profile that is associated with Nina is what I'm going to call the server, and this is just like you do with a single camera setup. It's connected to the telescope, it's connected to your roof system, it's connected to the focuser, and it's connected to the guider. And the beautiful thing about the plugin in its latest incarnation is that for the server, the main controlling equipment profile, you need to do very little to your existing sequences for them to run a dual camera setup. If we look at the plugins tab under the Target Scheduler, as before, we have the three main sections in which you look at and potentially can edit the database that runs behind the scenes. Under the first tab, Target Management, there are a number of projects, and under each project can be a list of targets. In this case I've grouped targets into LRGB natural colour sequences and narrowband sequences for nebula and deep sky stuff where I want nebula combined with natural colour stars. Under the exposure templates, again for each equipment profile, there's a list of standardized exposures for narrowband, star color and LRGB. And these are the defaults which are entered into the sequence and can be overridden if required. The important thing in this particular case is I'm using two different cameras, and they require different gain and offset and camera mode parameters. And the way that the sequencer has been set up with the Target Scheduler is that if you give the same name to your narrowband stars and LRGB exposures in both the server instance, which is the master, and also the client or the slave system, then when the exposures are made, it will adopt the specific exposure camera settings which are employed for each system. So you can have a high gain on one and a low gain on the other if that is what you require. But it only works if the names for the exposures are the same. The other thing to remind ourselves is that with regard to the different equipment profiles, that the client basically is a dumb system, and it isn't necessary to connect it to the telescope and to the guider and so on. And what happens is the scheduler passes information to the client so that it can take exposures at the right time. Basically when the telescope is guiding or it's stable, and allows it to do autofocusing on its own, but at the same time synchronizes operations between targets. There's one other thing you need to do, and that is to ensure that each of your profiles has synchronization enabled. So if you click on the profile name, in this case for the client, and bring up its preferences and scroll to the bottom, you'll see the synchronization preferences, and you need to enable synchronization for the profile, and here the timeouts for the wait for any action to complete and not synchronize with its friends, and also for centering and rotating. And that's also true for the server and any other profile that you're using in this synchronization relationship. So again, true and 5 minutes for each of the timeouts. Let's take a look at the Sequencer tab and how we construct a sequence for this special form of the plugin. Down the right hand side I have my standardized templates, and I've now adopted a naming system which reminds me what they're used for. So I have client and server versions, and when TS is in front of it, it means that the Target Scheduler plugin is being employed. The main one we're interested in is the exposure, and if we look at a standard Target Scheduler exposure and expand it out, it's fairly straightforward. We have a number of triggers for guiding, meridian flips, autofocus and center after drift, which are all in this section, in the normal trigger section. I have a loop while safe, and we have our target scheduler, which is populated at runtime with the target and the details of what's happening. And at the top we have a loop condition which basically loops until dawn or while targets remain for that particular imaging night. Further down, because I'm using a roll-off roof and we have a loop while safe condition above, if it becomes unsafe we park the scope and close the roof until things get better. And that is the basic imaging exposure part of the template. The one thing we have to add to it to work with two systems is a single instruction, and that instruction is now accompanied by all the other target scheduler instructions in its own little group, and this new one is called target scheduler sync wait, and we pop it in there. And what this does is it queues up both systems so that when the target scheduler is running and starting to populate targets and trigger exposures, that the two systems are in lockstep. Above and below this we can still use the target scheduler sync wait rather like the standard sync wait plugin, so that we can tie up things like initial autofocuses and so on. And if I collapse this down for a second, in fact I might remove it and bring in, so this is one of the new templates, and this is the initial startup, so it's opening the roof, cooling the system down, cooling the camera and making sure that the weather's still good. Right at the end, just before it actually goes into taking some pictures, I open the shutter, unpark the scope, I set my rotator to a fixed angle, I slew to an arbitrary part of the sky and do an autofocus, and either side of the autofocus is a new instruction, the one we've just used, called target scheduler sync wait, and there's one before the autofocus and one after. And this allows both systems, both the client and the server, to do autofocus at the same time and wait upon each other before carrying on. And this is one of the new parts of the imaging sequence with either dual or even triple scope systems. What I'm going to do is pull up my complete sequence, and I've actually stored one already. And the nice thing is with the target scheduler is you don't need to create a sequence for each different target. You just have a single sequence. So if we open that, it's made up of three parts. There's a shutdown part, the startup part that we've just looked at, and this modified initial one. So this is the one we've just created, where there's a target scheduler sync wait just put in before the scheduler container. And this is good to go. Just before we look at the client side of things, it's important to note that when you load Nina in the first instance, that you select the server profile first, and then select, when you load up a second or third Nina instance, that you then load your client profiles. It's the order of loading the Nina profiles that sets which one is in command. We're good to go, and I'm going to shrink this down and I'm going to load a client system. In this case I'm going to do a slightly different telescope and camera system with a sensor size that, strangely, the combination of which is very similar to my primary or my master or my server system, whichever you prefer to call it. So let's load this client system. Now, if I look in the Sequencer tab and look under my templates, I have startups for client and server. So if I look at my client one and open it up, it's pretty straightforward. It cools the camera, waits until dusk, and all it does is do an autofocus. And if you recall, we had two sync waits about an autofocus, and in preparation for taking the first images, it waits to be synced, it runs its autofocus, it then syncs again with the server system before moving on. It doesn't have to do anything with the telescope because the server is managing it. And in regard to connections, this system does not connect to the telescope or the guider, but it does connect to the safety monitor because that can be useful in some of the loop conditions. If I collapse this down and look at the exposure part, this is quite straightforward, verging on the trivial. So we have a main set of instructions which has two triggers, which is to autofocus. It doesn't have to worry about meridian flips or center after drift. It has a simple loop until time, till nautical dawn, I should say, not doom. That's something else. And whilst it's safe, it simply goes in a simple loop. It has a target scheduler sync wait and another new instruction called target scheduler sync container. So this is the equivalent of the target scheduler container in the server system. And it doesn't have to be populated with anything. It will be done automatically from the server system when it is run. And because this is a loop while safe, if I collapse that down, you can see that when it's not safe, it simply waits until it's safe again before trying to start off things. And the beautiful thing about this is that the sync waits do have a timeout period, but the scheduler sync container doesn't. So it can almost wait indefinitely for that to happen. And I believe if you don't run the client system, the server system will carry on as if there is no client. I'm going to collapse these down and remove them and just bring in my whole sequence, which not surprisingly is called scheduler client. And again, it's made up of three sections. We've looked at the first two, and the last one is simply the shutdown, which very simply warms the camera, disconnects the equipment, and has a target scheduler sync wait instruction at the end, so that the server system doesn't physically turn off the power until this has tried to disconnect all the equipment and make it nice and tidy. In essence, we've got everything we need. What I'm going to do is shut down my Nina versions and show how you would load and start a scheduled sequence of multiple cameras. So I've disconnected my two Nina versions to my equipment, and there's nothing running in Nina at the moment, so I'm going to open up the first one and I'm going to connect to the server, which is my longer telescope, which is also connected to a guide scope and to the mount. And I'm going to connect to my camera, and I'm going to connect to the rotator, which hopefully is the right one, and let it connect to all the other equipment. While it's doing that, I'm just going to move over and load a second version of Nina, and this is going to be for the client, which uses a shorter focal length but a smaller chip. So I can connect to this camera, and I'm going to connect to the rotator, but there's a slight problem in that it always defaults to the last rotator, so I've got to manually select the second rotator and connect to all the other kit. So on the client system, I connect to most devices apart from the guider. If we move into the sequencer, we can load our client sequence, and if I go to my other instance, which is this one here, into my sequencer and load the server sequence. To run this sequence, I would press run on the server, typically first, and then run on the client. And that's all I need to do. The wonderful thing about when it's running is, again, in the plugin, if you look at the install plugins and the target scheduler plugin and look at the target management and you look at a particular image, so it's going to take M33 today. Because I've used the same exposure template names for both the client and the server, it automatically links the revised gain and offset and the camera mode when it tells the client system to take a picture. There are a couple of other things to remind ourselves before leaving this page. Firstly, you only need to put targets into the instance of Nina that's associated with the server. You don't need to add targets to the client system. And secondly, when you look at the amount of exposures that you need and have been made and have been accepted, again, this is not just for the server system, but it's for all the systems that are currently being controlled by it as well. So this is the aggregate of both camera systems. When you run the sequence, the imaging tab is populated as before with its own images concerned with its own camera and telescope system, and the results of plate solving and rotation and solving and autofocuses are all shown in this window. In the sequencer tab itself, the scheduler container is populated with the target and what it's doing currently as normal. And in the client system, again, in its imaging tab, it too is showing the images as they come in, and it's showing its autofocus results, and it's showing HFR history for its own images. So almost like you're running two completely separate versions of Nina, but in the sequencer tab, the only thing that happens is on the target scheduler sync container line, it just says what it's doing. It's taking a picture of such and such, and it tells you the gain and offset. And when it's running, if the autofocus system for the client decides it needs to do an autofocus, it will go and do one. And because this is a sync instruction, it will automatically make sure that the server system doesn't do anything untoward whilst it's trying to do an autofocus, and vice versa. And just like with any multiple camera system, it's helpful if the master or the server system does not use an off-axis guider, because when you do and you try and do an autofocus event, it alters the tracking and it would mess up the slave or the client exposures. So I use a separate guide scope. I'm using refractors, which make that quite convenient, and the results are pretty robust. And that's about it. There are just a few little things to mention. If your equipment doesn't have a rotator, then it doesn't try to do a solve and rotate. If you do have a rotator on both systems, the client system will do a rotate solve and the server system will do a slew solve rotate, so that both have the same angle, and with multiple targets it will then repeat that for the next target if it's at a different angle. One other thing is that when it comes to the actual imaging saving options, that the file name system is preserved in both cases for both Nina instances, so you can resolve your images from both your systems and make sure you calibrate with the right flats and so on. And not to forget that as the images are saved, that they are graded, so in the plugin tab and when you look at acquired images, you can see that in some cases some of my files were not accepted due to exceptionally low star counts, and therefore extra exposures are taken in order to make sure I have sufficient. There's a couple here that were clearly something wrong with the tracking, or maybe some low cloud or something, because the half flux radius was too big. And that's about it. It's really powerful. It makes the sequence itself extremely simple because it's a constant no matter what targets you're using it with, and you simply do your editing in the target management tab of the plugin and can acquire a great deal of imaging hours for those precious few nights where the conditions are good. Thank you for watching.